Okay, so in this video, I am going to show you how you get from our starting material here, which is 2,2-dimethyl cyclohexanol, to our final product here, which would be 1,2-dimethyl cyclohexene. So how do we get that? And this is going to involve the formation of a methyl shift. So I'm going to show you all how that happens here. So the first thing we have to do is we're going to go ahead and rewrite this. And so I like to rewrite my reagent as a HOSO3, just like that. I mean, it's essentially, excuse me, and put an H here at the end. It's essentially the exact same thing. However, it's just a little bit easier to write out that way, because that way you don't have to draw out the entire Lewis structure, because that can be tedious. All right, so again, the first step we do, and you should always remember this. First thing you do is protonation. So this is a classic acid-base reaction. First thing you do is protonate. You always protonate. And what gets protonated is the alcohol here. So the alcohol gets protonated, right? So the electrons on oxygen go after the hydrogen there, and the oxygen gets protonated, and then the electrons from this bond jump on oxygen here on sulfuric acid, forming our classic hydronium ion here, plus hydrogen sulfate, so HSO4 minus, so it's hydrogen sulfate. Okay, so now we're ready to move on to the next step of the reaction, which is the formation of the leaving group, as the leaving group is going to leave. So the electrons from this bond, from that carbon to hydronium, are going to jump on oxygen, and you're going to form your leaving group. Excuse me, that's already your leaving group, and the leaving group is going to leave, is what I meant to say. So the leaving group is going to leave, leaving you with a secondary carbocation like so, right there. So that's your secondary carbocation, right? However, again, things like to go to things in nature always proceed towards a level of energy in which they are very, very low in energy. So the lower in energy you are, the more stable you are. And thermodynamically, a tertiary carbocation is favored over a secondary carbocation. And how do you form a tertiary carbocation here? Can you form a tertiary carbocation? Because right now we have a secondary carbocation. And the answer to that is yes, you can. And how does that happen is you're going to get a methyl shift. So this methyl group is going to shift right onto that carbon right there. So I'm going to call this a methyl, and that's a shift. And we are going to get this intermediate right there. And so now where did our carbocation go, however? Again, remember there was a hydrogen bond here. It's implied. It's not shown, but it's implied. So make sure you draw it out. If you forget that there's a hydrogen there, but that carbon there had 3 bonds, it gained a 4th bond now because we put a methyl group on there. So that's our 4th bond. Here's our hydrogen that I'm talking about. And so that carbon there no longer has a carbocation, because now this carbon here now has 4 bonds. So our carbocation therefore has moved back over here. So our carbocation has moved up here into the spot. And so we've therefore gone from a secondary carbocation to a tertiary carbocation. So now we have a tertiary carbocation. And that's the intermediate that's at play here. Okay, and moving on to the next slide here. So, and according to Zayd's rule, what is the major product that gets formed from the reaction? It's going to be the most substituted product. And in this case, remember we had a hydrogen here. So we can steal this hydrogen, and the electrons from this bond are going to collapse onto these 2 carbons, to form our quaternary substituted alkene here, which was the answer. Okay, and we reform our catalyst here, and we have some water in solution as well. Okay, so that's how we get this quaternary substituted alkene here. Sorry, so that's 1,2-dimethylcyclohexene. So that's how that happens. Yeah, can you form other products? Yes, you can, but this is going to be the major product here. Another product you could potentially form would be, this guy right there. You could also form that. You could also form, or you will also form this guy right here. But again, in solution, when you try and separate these out by their physical properties, this guy right here is going to be your major product, and that's how you form 1,2-dimethylcyclohexene from a dehydration reaction with a methyl shift.